All right, let's talk about something called FuzzBench. And honestly, the best way to get your head around it is to think of it like the Olympics, but for software that finds bugs.
We all rely on software for, well, pretty much everything, right? So, have you ever stopped to think about how huge companies find those really nasty security flaws before the hackers do?
Well, a huge part of the answer is that they use these incredibly powerful automated programs called fuzzers.
And to really get what these things are, just picture them as digital athletes. I mean it. They're in this constant, super high-stakes race to hunt down bugs and vulnerabilities buried deep inside our software.
But here's the thing. For the longest time, there was a huge problem. This race, it had no official rules, no standardized track, not even a clear finish line. So how on earth could you tell which one of your digital athletes was actually the best?
Okay, to figure that out, let's take a closer look at these bug hunters and see what they actually do.
So what exactly is fuzzing? At its core, it's pretty simple. You just automatically throw massive amounts of random, junky data at a program to see if you can make it crash. It might sound kind of basic, but believe me, it is unbelievably effective. At Google alone, this one technique has sniffed out tens of thousands of bugs.
And because it was so effective, you saw this explosion of different fuzzers, right? All built by different teams. But this just led to a whole new problem, a totally chaotic competition. And to really see how bad it got, check out this quote. Researchers looked at 32 different scientific papers on fuzzing, and their conclusion was just brutal. They said none of them gave enough evidence to back up their claims of being effective. The science itself was shaky because everyone was playing by their own rules.
So what you had was this old way of doing things that was just a fundamentally unfair race. I mean, imagine an Olympics where every single athlete runs on a different track, with different race lengths, using different stopwatches. It was impossible to compare them, and nobody could even reproduce the results to check the work.
And this chaos, it came at a huge cost. To run just one scientifically sound experiment the right way could take up to 11 CPU years. That's more than $2,000 on a commercial cloud platform. People were spending months just to set up a single race. And this is where our hero, FuzzBench, enters the story. Google created it to be the official rulebook for this entire sport.
Really, the best way to think of FuzzBench is as the free open-source Olympic committee for fuzzing. Its entire job is to standardize the whole competition so that every single one of those digital athletes competes on a level playing field.
Okay, so the FuzzBench rulebook is built on 4 key principles. First up, standardized events. Everybody competes on the exact same 22 real-world programs, no exceptions. Second, fair scoring. They use an independent, unbiased way to measure success for everyone. Third is rigorous judging. Each fuzzer runs 20 separate trials to make sure the results aren't just a lucky fluke. And finally, full transparency. Anyone, and I mean anyone, can check the results and reproduce the experiment for themselves.
So, with a fair set of rules finally in place, it was time for the main event, the Fuzzer leaderboard.
The FuzzBench team ran this absolutely massive experiment. We're talking nearly 13 CPU years of computation to pit the best of the best against each other. So after all that, who came out on top? Who took home the gold?
And here are the results. This diagram ranks all the fuzzers by their average performance. A fuzzer called AFL++ technically came out on top. But the really important thing to see here is that bold line. It connects all the fuzzers where the performance difference wasn't actually big enough to matter, statistically speaking. So yeah, while AFL++ was number 1, the top 7 athletes were all basically in a virtual tie for the gold medal. It was that close.
But FuzzBench can do more than just rank them. It can also analyze what each fuzzer finds. Which parts of the code one fuzzer found that another one missed entirely. And in this head-to-head matchup, a fuzzer called Entropic found over 10,000 unique parts of the code that libFuzzer missed. Compare that to libFuzzer, which only found about 400 that Entropic didn't. This just goes to show that some athletes aren't just better, they're way more thorough.
But here's the cool part. FuzzBench isn't just about ranking these athletes. It's also a world-class training facility for building better ones.
Think about it. Before FuzzBench, trying to improve a fuzzer was a lot of guesswork. The experiments took months to set up, they were slow, they were expensive. Now, with FuzzBench, developers can make data-driven decisions. They can run fast, free, and totally automated experiments to see if a change actually makes things better. It's a total game changer for the entire field.
And you can see the real-world impact so clearly. That top fuzzer, AFL++, It used FuzzBench data to learn that for short races, it's actually better to skip its slow warm-up phase. The libFuzzer team used the results to track down and fix a bug. And the developer of another one, HungFuzz, pretty much just watched what the other top athletes were doing and adopted their best techniques to get stronger. It's like they're all learning from each other.
So, okay, we've talked a lot about digital athletes and Olympic rulebooks. But why does any of this race really matter to the rest of us?
Well, the takeaway here is actually pretty simple. Better, stronger, and faster digital athletes means safer, more reliable software for every single one of us. Every single bug they find before a product ships is a potential hack, a data breach, or a system crash that we all get to avoid.
So FuzzBench has created this fair competition, this state-of-the-art training ground. The question that's left is this: as our world gets more and more complex, more connected, can these digital athletes, who are now training smarter and harder than ever before, actually win the endless race against the next critical bug?